Hello all, welcome to Code Hub. Let's solve today's LeetCode daily challenge. The problem is perfect squares. Given an integer n, return the least number of perfect square numbers that sum to n. A perfect square is an integer that is the square of an integer. In other words, it is the product of some integer with itself. For example, 1, 4, 9, 16 are perfect squares while 3 and 11 are not. So, given let's analyze the example. The example is n is equals to 12. So we want to form this target. Let us consider this as target n. We want to form this target n using perfect squares. So what are the perfect squares within the range 12? The perfect squares are 1, 4, 9 and then 16, but 16 is greater than 12. So obviously, yeah, it cannot be added into our solution. So let us consider this. So we want to form this target 12 using these 1, 4, 9. So how can we form this target 12? So uh, one such way is we can add 1 12 times. We can add 1 12 times and so on, and you can reach 12. This is one possible way. Here the steps needed is 12. So we want to minimize the number of steps that to form this target n. So let us consider some other way. If we consider some other way like 1 plus 1, which is formed 2, and again we can add a 1. We have formed 4 as of now using 4 ones, and we can add a 4 and we can add a 4. So this sums to 12, and the steps needed is 1 2 3 4 5 6, actually 6 steps. The 6 steps are needed for this particular option. So we can consider another option. Let us take 9, then a 1, then a 1, then a 1. As you can see that we are forming 12 using the perfect squares 9 and 1, and the steps here, the number of steps here are 4. So can we do this more optimal? Yeah, we can use 2 3 4s and we can form 12, and here the steps needed will be just 3. So this is what they are. This is what the problem states. We want to find the number of steps to reach the target such that they are all perfect squares, and we want to minimize our answer. So we want to find the more optimal answer. So for this we cannot form a greedy approach. Why can't we form the greedy approaches? We cannot the current optimal solution that we take may not lead to our optimal more optimal solution. So we cannot go for a greedy approach. I can prove the greedy approach by taking if the 149 want to reach target 12 using 149, we want to reach target 12. If we want to use a greedy approach, we obviously try to take the maximum number. So we will try to take a 9, then the balance is 4 now, sorry, the balance is 3 now, and we cannot take a 9 and we cannot take even 4, and we tend to take 1, and the left is 2. Again we will take 1, and the difference is 1 again. And as you can see that as I take maximum elements in our path, this greedy approach is not leading to the most optimal solution, because the optimal solution is 3, but while by doing a greedy approach we have reached 4 steps. So this is not going to work. So greedy does not work here. So now let us consider, if greedy is not possible, then obviously we can go for recursion by all possible cases. By trying out all possible cases in the sense, uh, if I have the squares, let us say 1, 4, 9. If I have the squares, we can either take this one or we can leave out this one and go for next. So this is nothing but the pick or not pick case. By using a pick or not pick, we can try out all possible ways and we can say whether we reach this target, and we will also take the minimum out of them. So we can go with that approach. So we can write the recursive solution, and where the recursive solution time complexity will be order of 2 power n. It will be exponential. We, for each step we will be going for two cases, either pick or not pick. And we can use a DP, we can use memoize the solution, and since there will be an overlapping sub problems, we can memoize the solution, and the overall time complexity will be reduced to order of m cross n. Let us see how we are going to do. So first we can try to form the squares vector. So let us say it as int. So the constraints are n equals to 10 power 4. So we can need a long. We can say it as squares. So how can we form the squares? It is very simple. From starting from 1 and I into I is lesser than or equals to n, we can just go for it, and we can add squares dot push back of I multiplied by I. In any case, I multiplied by I is equals to n. Then this is a perfect square, so we can just return 1. I hope this base condition is understandable. So now let us go for the recursive solution. So how can we do the recursive solution? We can say take the size of the squares vector first. So now we can write a function named, I'm naming it as solve. It starts from the 0th index and it is going to form this target n, and I'm going to pass the size as well, and we also need the squares. Now let us try to write the solve function. Int index I, int target, vector of int squares, int size. Whenever I have reached this size, my base condition is nothing but if my target is lesser than 0, then I cannot take that particular answer, so I want to eliminate that answer, so I will say it as int max. I am going to return a maximum value. Whenever I have reached the size, I have reached the size, then there is no possible value that I can take. So I want to form the target only. So I will say the target is reached to 0. I will return target equal to 0. It will either return true or false. Now I have two cases, int pick case, which is initially int max, and int not pick case. Not pick is simple. If I'm not picking this case, then I case then I will be incremented by 1. Then target will not be reduced, it stays the same. Squares vector and size. When I can pick this case? Only when the number, or else I can just say like this. Pick is nothing but when I pick this, I have used one move and solve. I stays the same because I take one perfect square infinite number of times. So I should be staying at the same index. Target will be reduced by squares of I. Then squares and size. So these are the two cases. I'm going to return the minimum of both the cases, pick and not pick. It is as simple as that. Just a small recursive standard recursive problem. So now let us try to, yeah, okay, it is a long so, yeah, actually it is going to return int max, so I will just have it as long and type it because 1 plus int max will be definitely a large number that cannot going to fit into our integer variable. So I will typecast here. Now let us try to run our code. Okay, actually we are getting a wrong answer. Let us observe. Now actually let us try to change our base conditions. If my target has reached 0 is equals to 0, then there is no possibility we can return 0. If my target is less than 0, or if my I is equals to size, then I can just return an int max. Now let us try to run our code. Okay, it gets accepted. So now let us use our example test cases. Okay, great. Super. Now let us try to memorize the solution. How we can memorize the solution? The parameters that are changing are target and I. I is nothing but the size, squares dot size. So let us declare a vector of dp, or we can initialize it here. It's a dp of 10 power 4 index so if n is going to be 10 power 4, then what will be the square root of this? It is nothing but 100. So obviously we are going to have the I in the range between 100. So let us have it as 111, simple. And the target can range till 10 power 4, so we can have it to be in 1001. Now let us try to memset dp minus 1 size of dp. If my dp is already solved, if this is already solved, if my I target is not equals to -1, then return dp of I target. And here dp of I target. Now let us try to run our code. So now it gets accepted. Now let us submit our answer. So it gets accepted. Hope you like the solution, and let me also try to reduce this space complexity. Now let us try to do that. So actually I'm doing a actually I'm building the squares vector. So instead of building the squares vector, what we can do is we can on the go we can try to make that squares vector. How we can do that is, instead of making this squares vector, while doing this recursive solution, we start with 1. So we are going to see I multiplied by I, and we are sorry, instead of the squares of I, it is nothing but I multiplied with I. Right, right. We can eliminate the squares vector as well, and here also, and even here. Sorry. And I hope that's it. I plus 1, and yeah, this squares is nothing but the I multiplied by I. So instead of that squares vector, we can have it like this. Now let us try to run our code. Sorry, this is not going to be there. Even we can eliminate the size as well. So just we are going to call this recursive function starting with 1 and n, and if at all like this, if my target is less than 0, we can just return int max, and if it is already solved, we can just return this. We can also check if my I multiplied by I is going to be greater than target, we can just return int max. So why is that okay, now let us have it like this. If my I is greater than 101, return int max. Now it will not go out of bounds, I guess. Okay, there is some other case. Let us observe what is happening here. Sorry, actually, if we have to say it as OR condition, or else we can keep this condition to be like this. If my I multiplied by I is going to be greater than target, we can just return int max. Okay, that's backend missing here. So this will be so simple, and the similar step without building that squares array, we are actually doing this. So it is quite simple. So now let us submit our code. So it gets accepted. Hope you like this solution.